Okay, in this lecture we're going to talk about externalities. Externalities can be either positive or negative. They can either be on the production side of the market or on the consumption side of the market. Probably the best way to go over and talk about externalities is to kind of go through an example, hypothetical example. And so the one I've chosen to kind of go over and talk about today is a water pollution problem, a negative externality. Very typical sort of environmental economics type of problem. So what we could imagine here in this problem is that we're producing paper. Maybe think of this as out in the Midwest 30, 40, 50 years ago, where you had paper mills that might be along a stretch of one of the major rivers, taking in the water, using that water to process the timber into pulp and then into paper. And of course, one of the byproducts of that paper production process was chlorine, for example, and dioxins that were then put back into the river as effluent. Now, 30, 40, 50 years ago, the problems that we might have seen as a result of this effluent weren't quite as obvious as they then became maybe 20 years ago or so. So it took some time for the cost, the negative externalities, to actually emerge. These negative externalities emerge or are discovered when we finally find some people who are willing to pay others to stop the production of these negative externalities. So it's then that we know that these externalities become an economic problem. It could be another manufacturing plant that uses clean water that has to clean the water up downriver. It could be people that live along the river. It could be hunters. It could be fishermen. It could be naturalists that use the area around the river. When these people feel as though there are damages to them and they are then willing to pay to try to reduce these damages, then the externality moves from an environmental problem to an economic problem. And so we're kind of imagining that process happening, and we're going to estimate what the damages are as a result of producing paper along this river. So we're looking here at a graph. We've got tons of paper on the x-axis in millions of tons. We have the price of paper along the y-axis, the supply function, the demand function. We can see that the demand function is labeled the marginal social benefit function, an indication here that we have both the private benefits and the external benefits added together, meaning that there's no market failure on the consumption side of the market. We can see that the supply function, which represents the cost of producing paper, right now is labeled the marginal private cost function. That's sort of an indication here that we don't necessarily have the social costs of producing paper established, and therefore we might be missing some of the external costs associated with the production of paper. We only have the private costs. We have the cost of the land, labor, the capital, and the entrepreneurial skill. And so this might be the graph for a paper mill or the paper market, if you will, out in the Midwest 20, 30, 40 years ago. Maybe this is yearly information, and we can see that the private cost, where intersects the marginal private cost intersects the marginal social benefit, indicates the competitive market equilibrium for the market for paper. Often referred to it as the competitive market because this is the free market, if you will. It's not a market that is subject to any regulation that might be dealing with the pollution problem, and we're getting to that point. So in the free market, in the competitive market, the equilibrium can be established. Price of $800 per ton, 5 million tons of paper being produced. And what we need to do next is we need to consider the possibility that the production of this paper is actually generating a negative externality, and then measure that negative externality. So this is where environmental economics becomes very interdisciplinary. To do this kind of work, we would have to have all sorts of scientists in various areas of this water pollution problem try to identify and quantify what the externalities are. Obviously, we could talk about the drinking water potential problem. We could, from the standpoint of people getting sick, maybe even people dying from consuming polluted water. We could talk about the effects on flora and fauna along the river. We could talk about the effects on other industries and businesses, whether it's a tourism industry, a hunting industry, a fishing industry, or another manufacturing industry that uses the water. We could talk about the engineering costs that might be involved in putting in water treatment facilities in order to clean the water. So these are all sorts of different areas where we can look to find what some of the external costs might be, and then go to economists to help quantify those costs. Some of them are going to be easy to quantify. We can look at medical records, and we can look at the number of individuals who have been diagnosed with a certain disease or who have died from exposure, and we can then look at their costs, and from the standpoint of how much did we spend on their medical care. We can use value of human life that's established by economists and used by government to put a dollar value on mortality as a result of drinking the water. And we can look at engineering costs for putting in water treatment facilities. We can look at firms who have to put in water treatment operations in order to turn the water into something that they can use in their businesses. And then, we get to some of the ones that are a little bit harder to put a dollar value on. Those would be the effects to flora and fauna. Maybe, we can look at hunting licenses and tourism revenues and all that kind of stuff. But then you get down to this existence value kind of thing, just the idea that these organisms, plants, mammals exist in these areas. That gets a little bit more difficult. Now that's a topic that we're going to get to, the measurement of the costs or the measurement of the benefits to the environment, and how we would actually try to get at a dollar value that we would then use in a model like this to try to then understand and quantify the problem that would then lead us to some kind of policy prescription. We're going to get to that in a later topic. But for right now, we're just going to sort of look at it operationally, model it, and look at the technical side of it here, the mathematical side of it. So what we need to do is we need to identify these externalities, and then we need to quantify to the best of our ability what these externalities mean in terms of the trade-offs that people make. And that's where economists can be helpful. So let's assume that we do that. Let's assume that we actually quantify these costs, and we'll use this graph to sort of do this. So let's imagine then that after doing all this scientific work and working with economists to try to then quantify all of this science, we calculate that for every ton of pollution or for every ton of paper that's produced, there's $50 of marginal external cost or marginal damages. Sometimes this concept is referred to as marginal damages, or MD. It makes intuitive sense to call it that. But these are the damages that are being done by each additional unit of the goods. That's why the marginal concept is there, each additional unit. And these directly translate into the marginal external cost. So we're saying that for every ton of paper, there's $50 worth of damage that's being done. So therefore, the marginal external cost is 50. So another way of sort of interpreting that is that the 5 millionth ton, so that exact one, the 5 millionth ton, would cost the firms to produce it in terms of land, labor, capital, and entrepreneurial ability, $800. That's just the private cost. What we're now saying is, based on all the research that's been done by the scientists and the economists quantifying this, we've identified that there's another $50 in actual external cost to third parties, which we need to add into the private cost. And so therefore, the 5 millionth ton really costs society $850 in marginal social cost, indicated by S star. So basically what we're doing is saying that every single ton has this same difference between the private and the external, or that we need to add the external to the private. And so we can see that for every single ton, we're adding $50. Okay? So we can see this slide just shows what I was just talking about with the 5 millionth ton, noting that the 5 millionth ton is causing a negative externality, is causing deadweight loss, such that the marginal social cost is greater than the marginal social benefit by $50. Now, if we look at the 4,999,000 ton, that ton is also producing $50 of damages, And we can see that right here. And we could talk about the 4,999,998th ton, and so on, and so on, and so on, and so on, and so on. So we could actually estimate this area right here as the total damages that are being done as a result of producing 5 million tons as opposed to 4.5 million tons, which would be the socially acceptable level of paper production and hence the socially efficient level of pollution as well. So we know that we're not going to produce zero, because producing zero would mean absolutely no paper, so people need to make a decision about how they want to allocate their dollars towards pollution prevention and towards consuming this product that also gives them utility and happiness and usage. It also creates jobs for the community. We'll come back and talk about that for a minute too. So it's about finding a level that people are willing to live with, and the demand function tells us the benefits that people get from the product, and now we have to equate the benefits that we derive from the product with the overall social cost of producing the product, which includes the marginal external cost. And we can see that that results in a new equilibrium of $835 for a ton of paper and 4.5 million tons of paper. So 835 is now the socially efficient equilibrium, right? And 4.5 million tons is a socially efficient equilibrium, and $835 is the socially efficient price. That's now, that as a result of doing this research and this work and quantifying this and putting it back into the graph, we can see where society wants to be or should be to be efficient. And currently, of course, society is still back here at 5 million tons. So the next step in this process will be figuring out solutions to actually get the market to move from where it's currently inefficient at 5 million tons to where it's efficient at 4.5 million tons, given the information in this problem. So we can just make sure we understand what's going on in this graph and being able to intuitively describe what's going on, we can ask ourselves some questions. So why has the price of paper only gone up $35 when the external cost or damage per ton is $50? Well, we could look at this as, when would the price go up $50? Well, the price would go up $50 if people were completely unresponsive in terms of their consumption of paper to a change in price. Meaning if the demand curve was perfectly vertical, a vertical line that went straight down through the equilibrium at 805 million tons, then when we add in the marginal external cost, we can see that the new price would go to $850. So only under the condition that the demand for paper is perfectly inelastic, meaning people are completely unresponsive to a change in price and will not switch away and will continue to consume the same quantity of paper no matter what, that's the only time that the price would actually go up 50. So the answer to this question is that because people are responsive to price when it comes to paper and will decrease their consumption and will find substitutes that they'll be able to use potentially in lieu of paper, other kinds of papers or other kinds of products, the price actually doesn't go up to full 50, it goes up something less than the full 50. Well, one thing that we can notice, and let me just go ahead and erase what we had up here. One thing that we notice is that the price goes up $35 up to $50. So from that information alone, we can tell that consumers are somewhat unresponsive to price. If they were very responsive to price, we might expect the price only going up $5 or $10, and as a result, we would get a really big change in consumption and a very small change in price, right? So we can see from this information, this hypothetical situation, but it allows us just to understand economics a little bit better. We can see in this problem, right, that the consumer is somewhat unresponsive, is willing to pay $35 of the total $50 of the marginal external cost. Well, then that means then, right, that the firms are having to pay the other $15 of the $50. And we can see that actually right here. At the new socially efficient equilibrium, we come straight across from there, right, which is the 4.5 millionth ton of paper being produced. We know that the 4.5 millionth ton of paper must have cost society to produce it $785 in terms of land, labor, capital, and entrepreneurial skill, just the private cost of production. But then throw on top of that the fact that the 4.5 millionth ton, that one, also costs another $50 in damages. That gets us to $835 for the 4.5 millionth one. So we can see here that the producer is going to end up, in a sense, paying $15 for every ton of paper being produced in terms of lost profits or a decrease in consumption of paper because people switch away. And consumers are going to pay the other $35 in the $50 marginal external cost because, you know, they still need and paper, it's still a productive product for them, and therefore they're not completely willing to switch away. They still need to consume some quantity. So that's how we would interpret that information. So the elasticity of demand and the elasticity of supply, but in this case the elasticity of demand, really sort of explains who's going to bear the burden of this pollution problem, whether it's going to be the consumer or the producer. In this case, it's going to be the consumer because demand is relatively inelastic. And again, we can see that because they're paying more than half of that $50. What has society gained? Well, we talked about this before, that society has gained the fact that we've reduced pollution to some level that we're willing to live with, right? We've seen the result here of this analysis is that society would be better off with only 4.5 million tons of paper being produced, which is a decrease of 500,000 tons of paper, and thus the corresponding pollution that goes along with 500,000 tons of paper. So society has gained that in terms of a cleaner environment. However, there's also a loss or a cost that society is going to bear from the standpoint that because 500,000 fewer tons of paper are going to be produced, it means then that the resources that would normally go into producing that 500,000 tons aren't going to be needed anymore. That could mean jobs, that has an impact on communities, and so there is some cost to the firms and to the communities, to the economic pie, if you will, as a result of this move, and we'll talk about that in a little bit. So have we eliminated water pollution? No, we haven't eliminated water pollution. We've reduced it, though, to a level that we're willing to live with. The full elimination of water pollution would only come at the full elimination of paper, and people still derive benefits from paper. Communities still derive benefits from the production of the good that creates jobs and livelihoods and standards of living. So there's a balance that has to be established. Economics doesn't necessarily have too much to say about whether 4.5 or it's 5 or whatever the actual outcome is. People have something to say about that. It's all about the measurement of the damage that's going to then lead us to the correct answer. So it's crucial that we have good techniques, effective statistical analysis that can help us quantify these damages that are being done as accurately as absolutely possible, such that then the outcomes fully reflect those costs. This is just a hypothetical. And we've already answered this last question, what does the price tell us about the elasticity of paper? We already said that it's somewhat inelastic as a result of consumers paying more than half of the actual external cost. So we can look at a couple of different things here now quantitatively that we just talked about. We can talk about the total external cost. The total external cost would be summing up all of the marginal external costs. So the total external cost associated with the 5 million tons of paper that are currently being produced that we haven't done anything about yet. We know that we need to. We know where we want to be. We want to be at 4.5 million tons, but we're currently still here at 5. Then what we could do in order to calculate the total external cost is to multiply the marginal external cost back times the actual quantity. We'll call it the competitive quantity, right? The free market quantity, the quantity that's before we actually do anything. That's the 5 million tons. And so therefore we could look at that as being $50 million of total external cost, which would be the area between the two supply functions, which represents the marginal external cost summed up all the way back to the origin. So that area right there would represent our total external cost. We're just going to get rid of this before we go on. Now the deadweight loss, as we know in this case, the deadweight loss is due to overproduction, meaning that the production of paper at 5 million tons has a marginal social cost that's greater than the marginal social benefit, indicating a deadweight loss, indicating an inefficiency, and we can see that that inefficiency is $50. We know that if we move from 5 million tons to 4.5 million tons, that the amount of damage that's eliminated in total, so the total external cost portion of the damage that's eliminated for the 500,000 tons in between 5 million and 4.5 million, would be this area right here, right? That would be the total benefits that we would get by reducing pollution from 5 to 4.5 million. But remember I talked about how this is also going to result in 500,000 fewer tons of paper, resulting lost jobs, maybe the lower standard of living, effects on the community, a shrinking of the economic pie. So those losses, as a result, have to be netted out of the gains of the reduced pollution. So if the blue area represents the gains of the reduced pollution, this triangle underneath here actually represents then the losses as a result of producing less of this product than what we had originally. And therefore, what's left over is the blue triangle that we're familiar with from this discussion before, that represents, and I'll call it green triangle, right, that represents our deadweight loss, which is also referred to as a net gain in social welfare when we take a deadweight loss and we correct it. So if we were to get the market to move from 5 million, where we know it's inefficient, to 4.5 million, where we know it's efficient, then what was a deadweight loss at 5 million would then become a net gain in social welfare at 4.5 million, and that net gain, because it's net, is really net of the total damages, or total benefits, if you will, from moving from 5 to 4.5, which was the blue area before, net of the red triangle, which is the cost of firms and communities, leaving us what's left over, the green triangle, known as the net gain in social welfare. So these two concepts are synonymous. They're just used, the language is just used depending on whether we're talking about the current state of the world having an externality, thus it's a deadweight loss, or the correction of that externality, which then turns into a potential net gain in social welfare. And that's 1/2 base times height. And we know here in this particular example that the height of the triangle is 500,000 units, and the base of this triangle is $50. So we can multiply that out and get the deadweight loss. Okay?